Anyone please elaborate? Yes.
Milliman's method and measure loop current method.
Yes. Last class we have studied how we are going to solve or analyze three-phase unbalanced load with the application of Millman's theorem and mesh or loop current method. Okay, today we are going to see a problem on by applying Millman's theorem. Okay, here I'll type the question. Everyone please note it down. Okay, a symmetrical, it's visible, right? Or can I increase the font? Okay. A. Everyone please note down. Electrical 440 volts, three phase system supplied a star connected load with the branch impedances are here ZR equals to 10 ohm. Then ZY equals to J 5 ohm and ZB minus J 5 ohm. Now we need to calculate. See, in a question they might be given as a ZA, ZB, ZC or ZR, ZY, ZB. Just three phases we need to mention. The notations will be different. Okay, calculate voltage drop across each branch and the potential difference between neutral and star point and the phase sequence is RYB. Okay, then draw phasor diagram. Okay, this is the question given. The symmetrical 440 volt three-phase system supplied a star connected load with the branch impedances as ZR, ZY, ZB. Now we need to calculate the voltage drop across each branch. Difference between neutral and the each branch in the sense calculate yes What we need to calculate? Voltage drop across each branch. Last class, V or not, VI not, VB not. Then the potential difference between neutral and star point, that is VRN, VYN, VBN. Got it? Now let us consider this. See, question they have asked. This is the diagram. This is ZR, sorry, ZY and ZB. This is the neutral point. Okay, they given this one as 10 ohm, this one as J 5 ohm, this one as minus J 5 ohm. Fine. This is supplied by 440 volt 3-phase supply. Means we know this is R, this is Y, this is B. Okay, R, Y, B. Correct. IR is flowing here, IY is flowing here, IB is flowing here. IR, IY, IB. Okay. We need to calculate across each phase. First, VRY, line voltages. See here. VRY, VYB, then VBR. Now, here, this is O. What is O? I already explained the last class. What is O? Anyone?
Neutral.
Neutral of the supply point.
It's a
O is
neutral.
the, yeah, O is the neutral of supply. N is the neutral of load. Okay. Now let us, we need to calculate. See this 440 is phase or line voltage. Whatever the voltage is given in the, always it will be a line voltage. We know the formula for line voltage and phase voltage. Okay, V phase is equals to V line divided by root 3 for star connection. Correct or not? This is, say na, V is equal to V line by root 3. Yes. Now we need to calculate V or not. That is phase voltage. V R to this, V R to this not. Then V Y to this not. Then VV to this not. Means we are calculating the phase voltages. Whatever the voltage given in the problem, most of the time in the examination they will give the line voltages. Okay, now we need to calculate phi phase, phi r naught, phi y naught and phi b naught. Phi r naught is given by V line by root 3. So my line voltage is 440, yes, divided by root 3. Now tell me what is the angle I need to mention here for VR? Yes. What is the angle mention for? Yes, guys.
0 degree.
0 degree. Why? Because in the question they have given that phase sequence is RYB. So I am going to take this R as my reference. So 0 degree minus 120 degree minus 240 degree. Okay. Now I'm going to mention this one as 0 degree. Then coming to VR naught. Say how much is this? Tell me. Here minus 120 degree. 450 by root 3. Here this is minus 240 or plus 120 degree. Okay. Plus 120 degree. Yeah. Calculate and tell me. Use the calculator
254
fastly. First one is 240. How much?
254.03 volts.
03 volts. Okay. So
Volts.
here 0 degree. So simply I will make this one as 0 volts. Now next. Phi I naught. Phi y naught. I'll get as minus 127.01 minus of J 220 volts. Okay, kindly verify this one. Then I'll get VB naught as minus 127.01 plus J 220 volts. Okay, now tell me, this is in the form of A plus B. I'm going to call this form as, which type of form is this? Polar or rectangular?
Rectangular.
Pole.
This is a rectangular form. This is in the rectangular form. Okay, I got VR naught, VY naught and VB naught. Okay, now last class we have seen how we are going to use the Millman's theorem. Okay, we know I have written the formula like phi n naught is equals to phi r naught into phi r plus phi y naught into yy. It means phase voltage into admittance. Okay, here in the question ZR, ZY, ZB are given. Okay, first we'll calculate those things. Okay, ZR is given as 10 plus J0. ZB is given as 0 plus J5. ZC is given as 0 minus J5. Now, tell me YR is equals to 1 by ZR. YB is equals to 1 by ZB. YC is equals to 1 by ZC. Please tell me the values for YR, YB, YC. Long back I have said that for derivation, division and multiplication, we are going to use polar form, right? And for addition and subtraction, we are going to use a rectangular form. Fine. Here yr equal to 1 by ZR is there. Okay. I need to calculate that 1 by 10 plus j into polar form. That is, if I'm going to calculate this 10 plus j0 into polar form, I'll get 10 and angle of 0 degree. So my yr will be 1 by 10, that is 0.1 and angle of 0 degree. What is the unit for admittance?
Mo.
Mo. Okay. Similarly, 1 by 0 plus j 5u. Okay. If I'm going to convert this one to polar form, 1 divided by 5 and angle of 90 degree, then yb I'll get as 0.2, 1 by 5, 0.2, angle of minus 90 degree. Mo. Then coming to ZC, 1 by 0 minus j 0.5, 0.5. So I'll get 1 by 5 and angle of minus 90 degree. So I'll get YC as 0.2 plus 90 degree mo. Okay. From ZR, ZB, ZC, we have calculated YR, YB, YC. YR is 0.1 angle of 0, YB is 0.2 angle of minus 90 degree, YC is 0.2 an angle of 90 degree. Okay. Now, according to the Millman's theorem, we know that yn naught. Last class, I have mentioned this formula for Millman's theorem. Okay, now we'll see. Please note it down. When I will ask questions, I don't know. Okay, it will be absent for you guys. Yeah. Now, according to Millman's theorem, according to Millman's, I know phi n naught is equals to phi r naught yr plus phi yy phi b naught, this is plus phi b naught yb divided by yr yb, sorry, yy plus yb. Okay, we know vr naught, vy naught, vb naught. We know yr, yb, yc. Then simply calculate phi n naught. Yes. Please write it down. And tell me the answer first. 0.3 plus J0 into YR is 0.1 angle of 0 plus or minus, I'll take minus only, minus 127.01 minus J 220 into 0.2 angle of 90 degree, then minus 127.01 plus J 220 into 0.2 an angle of 90 degree divided by 0.1 angle of 0 plus 0.2 angle of minus 90 degree plus 0.2 an angle of 90 degree. Okay, after solving this, I'll get phi n naught as phi n naught is equals to phi n naught is equals to 626. See, you need to calculate and maintain the nodes for ECA. Okay, 626, the angle of 0 degree volts. After solving this phi n naught, I'll get 626 angle of 0 degree volts. That is, I can simply write as in a rectangular form 626 plus J0 degree, J0 volts. This is V N naught. Okay, now we know VR naught, Vy naught, Vb naught. Then we need to calculate. See, phase voltages we have calculated VR naught, Vy naught, Vb naught. Okay, now we need to calculate. Yes, what is the question? Yes, anyone?
Potential difference between neutral and star
Yeah,
point.
now we need to calculate the voltage between neutral and phase. That is R to N, Y to N, B to N. First class for this three-phase unbalanced load, we have seen the formula for VRN, V and VBN. Okay, just recall that one. This. Okay, you know VRN, VR naught plus VON. Then VYN is equals to, yeah, VY naught, then plus
VON.
VON, then VBN,
VB
VB
naught.
naught plus VON.
VON.
What is O here? What is N here?
N is the load neutral point.
Yes.
O is the
The
phase
connection from neutral of supply to that load neutral.
supply
Yes.
neutral. O
Here,
is
N is the neutral of load point. O is the neutral of supply point. Here, how I can going to define this one? If this is my star connected load and this is my RYB and a neutral supply O. Okay, I'm going to connect the R to this, Y to this, and B to this. This is N. If I'm going to connect this one to here, what is the voltage between N and O point? That is this one, VON. Okay, in question they have asked this VRN, VYN, VBN. Now we need to calculate those. Okay, first. Just only we have calculated VN. What is the value for that? Tell me.
626 plus 0 J volts.
26
Yeah,
and
0 volts. Okay. Now V RN formula VR naught plus V ON. I can write this one as, see here, see here. I can write this one. Here ON is there, he is. See, we have calculated the value for VNO, not ON. Okay, we have calculated the value for VNO. You just check once. 626 plus J0 is VNO.
sir VNO.
Yeah, VNO. Here is VON. So this sign will change. That is VR equal to VR naught minus of VON. equals to minus of phi on. Just check your no and on. Okay, now I know phi rn is equals to my VR naught is 254.03.J0 and this is 260.26.J0. I'll get some value. Okay, for same phi yn phi y naught minus of phi on, then phi bn equals to phi b naught minus of phi on. Okay, I'll get some value. Okay, next class I will ask the values for phi rn, phi y1 and phi bn. Okay, fine.
Yes, sir.
Yeah. Now
Yes, sir.
everyone knows star delta transformations, right? Star to delta transformation. Okay, if this is my star connected load, how I'm going to transfer this one to this is star or delta?
Delta.
Yeah. So you people are simply at least say when I'm saying that the delta connected load to star, then there's a no sir, this is star like that. Okay, delta to star. Okay, now this is 1, 2, 3 terminals ZA, ZB, ZC. Then 1. See, it's already you have studied. This is third time you are. I am explaining this one to you. Okay, basic first and first unit second. This is a time term. Now tell me Z1 Z1 equals to ZA ZB divided by
Divided by
ZA plus ZB plus
ZA plus
ZC.
ZB plus ZC.
Okay, tell me Z2
ZB ZC divided by ZF.
yes ZB ZC divided by ZA plus
ZA plus
ZB
ZB
plus
plus
ZC.
ZC.
Okay, now final Z3
ZC ZA divided by
ZC
ZF.
ZA by
ZA
ZA plus
ZC or
ZB
ZC
plus ZC.
ZA divided by ZA plus ZB plus ZC. Okay, these are formula known to you, right? Correct?
Yes, sir.
Now see here. Now tell me these formula also. ZA, ZB and ZC. If I'm going to transfer the star to delta, ZA.
Z1 plus Z3
Z1 plus Z
Z3
plus Z1
plus
Z3 divided by
Z1 Z3 by Z2.
Z2. Okay, next
Z1 plus Z2 plus Z1 Z2 by Z3.
plus Z1 Z3.
Z1
Next.
plus Z.
Z1 Z2 by Z3. Here
Yes, sir.
Z2
plus
plus
Z2
2 plus
Z3
Z3 plus Z2 Z3 by Z1.
yes.
Z1.
Okay. These are the formula for delta to star and star to delta. Okay. Now We'll see on problem quickly on this for unbalanced load. If load is unbalanced, how we are going to solve the problem with Millman's. Okay. No, a three phase. We'll change this color. A three phase. Three wire. Three phase, three wire. 208 volt. See again, there in the first problem, what he mentioned, RYB system. Okay, here ABC system. Just notations are different. Okay, ABC system has a star connected, unbalanced load with ZA equals to 5. 1 minute, guys. Yes. ZA equals to 5 and angle of 0 degree. 5 angle symbol what I have to take here. I'll take this one, okay? No problem. Huh? Just understand that is the angle. 0 degree. It is 0 degree ohm. Okay, now ZB is 5 and angle of 30. Angle of 30. Then ten angle of minus 60. 10 angle of minus 60 ohm. Okay, now we ask obtain the line currents and voltages across each impedance using our delta transformation. Okay, we already know, just only we have seen the formulas for star delta and delta to star transformation formulas. So here they ask a three phase, three wire 208 ABC system, that is RYB system, has a star connected unbalanced load with ZA, ZB, ZC. Some values are given. Now obtain the line currents and the voltage across each impedance using that transformation technique. For your simplification, I am going to give, okay, for simplification, I'll give a diagram, three phase, three wire, star connected. Neutral is not there. It means ZA, ZB, ZC. Here this is ZA, ZB, ZC. Okay. A, B, this is a form problem given. This one is 5 angle of 0. P is 5 and angle of 30. C is 10 angle of minus 60. This is ABC, nothing but R by B. A, B, C. That is A, B, C. R, Y, B. Okay, this is the neutral point. Three wire, three phase system. We need to transfer this one to delta. Okay, here also A, okay, A, B, C. This is a point A, this is a point B, this is point C. A to B. Huh. Tell me, this is ZA, this is A to B. What can I call it as? ZAB, B to ZBC, C to A, CA. Correct? Now
Yeah.
current flowing in this phase is IAB, current flowing this phase is IAC, current flowing this phase is ICA. Okay, this is the given star network. Now we have converted that one to equivalent delta network. Okay, now we need to calculate ZAB, ZBC, ZCA. That is nothing but ZA, ZB, ZC. Fine. Now calculate and tell me ZA, ZB, ZC. See, in an examination, if you have given this type of problem, first you need to draw that given network. It's a star or delta. Then equivalent delta or star. Okay. Now here in this question they have star network. So drawn a equivalent delta network. Okay. Now from this, what I get to know? ZAB, yes, ZBC, then ZCA. You can see here ZAB, ZBC, ZCA, and current flowing through those branches IAB, IBC, then ICA. Okay, now I can simply write this one. Don't confuse with ZA, ZB, ZC. ZA, ZB, ZC. We know the formula for this. Okay, and simply one I will solve, rest we can solve it afterwards. See, ZA is equals to means Z1, Z3, 3 by Z2. Solve for ZA, ZB, ZC. In question they have given ZA, ZB, ZC, sir. I am just simply taking this one as ZAB. So this one is A, 3 is C, A, C, 2 is B. In question for star they have given as ZA. 1 is A means A, B, C is there, Y, R, sorry, C, R, Y, B, 1, 2, 3. I can take this one. Now here I can write this one as ZA, ZR, ZR, Z1. This one ZB, ZY, Z2. This one ZC, ZB, Z3. Okay, calculate ZA, ZB, ZC. We will get some values. Then the phase sequence is ABC. So VA B, VBC and VCA. We need to calculate. See here. In question they have given us 208 volts. This is line voltage or phase voltage? Yes guys, line voltage or phase voltage? Just only I have told. This is line voltage or phase voltage? Simple question. Yes. Sai?
Line voltage.
Sir, I think phase voltage.
Line voltage.
Line voltage.
Whatever the voltage given in the numerical, okay, because it's a star connected thing, VB, VB, VA to VC. So we have already connected the drawn the equivalent delta networks. So we know that for a delta network, phase voltage and line voltage are same or not, equal or not? For delta network, phase voltage is equal to line voltage. So it's given as line voltage. Now I need to calculate VA. Phase sequence is VAB. So 208 and angle of 0 degree volts. VB 208 and angle of minus 120 degree volts. VC 208 and angle of plus 120 degree volt. This is VAB, VA, VB, VC. I can simply call it as VAB, VBC, VCA, phase voltages. Okay, now we need to calculate IAB, that is VAB divided by ZAB. Then IBC, that is VBC divided by ZBC. Then ICA, that is VCA divided by ZCA. After calculating VAB, VBC, VCA and IAB, IBC and ICA, I need to calculate line current. Because in question they have asked, we need to calculate the line currents. Okay, for that we see here ICA. Here, this is IA. 1 minute. Yeah, this is IA, this is IB, this is IC. Okay, my line current is IA, IB and IC. We need to calculate IA, IB, IC. Here IA is equals to, see here, if IA comes here, IAB, then minus of ICA. Then if IA is here, see for B, IB is here, then IBC minus of IAB, because opposite. Okay, it's leaving. Now IC, tell me for IC. IC is here, ICA minus of, yes, for IC you need to tell me. IA, IAB minus ICA, IB, IBC minus IAB, IC, tell me. Yes. This IC I am talking about.
ICA minus
ICA minus of IBC. Okay, we have calculated the voltage across the impedances VAB, VBC, VCA. Then we have calculated the line currents IA, IB, IC. Okay.